Hello, I'm your host, Dr. David Urban, and I will be guiding you through Brown and Poon's Introduction to Organic Chemistry, 6th edition. The slides were downloaded from the Wiley Instructor Companion site and are copyrighted by Wiley. The commentary is my own. I have divided each chapter into smaller sections to make it easier to view on a wide variety of platforms. So let's begin. We will continue with Chapter 3, Part 2, Alkanes and Cycloalkanes. In this chapter, we're going to talk about the IUPAC nomenclature associated with that system. The IUPAC is the International Union of Pure and Applied Chemistry, and so they set the rules over how we name these things. And we have a nice systematic name for everything such that we have an unambiguous way to say we have exactly this constitutional isomer versus this constitutional isomer by using our IUPAC nomenclature method. Okay, all hydrocarbons that are unsaturated fall under what we call the alkanes. And alkanes are to take the numbers, the prefix used to decide which kind of how many carbons we have, and we add the suffix ane to say that it's a fully saturated hydrocarbon. Okay, so the prefix tells us the number of carbons, and the three we have to memorize are the four we have to memorize are the ones at the top, because that's meth, eth, prop, and bute, because they are outside the normal metric system. The rest of them follow the metric system where it's penta, hexa, hepta, octa, nona, and deca. So those follow the nice simple rules of penta is 5, octa is 8, trideca is 3 plus 10 is 13. So those follow a nice simple method, and we need to keep that in mind. So the four at the beginning here are the ones we got to pay attention to. Meth is 1, eth is 2, prop is 3, and bute is 4. Okay, and we of course add the ane at the end to show we have an alkane. Okay, so there are several rules we must follow, and what we're going to do is, as we go through this, we're going to start with 7 simple rules, and then we're going to keep adding to them as we add functionality, as we add a double bond, as we add a triple bond, as we add an alcohol. So, but we're going to use the same step method, starting with the parent name. Okay, the parent name is the longest carbon chain. Okay, now if you have a long carbon chain, then you have a small chain coming off it. That small chain coming off it, if it's bonded to that, it is a substituent. Okay, so if the substituent is only made of your substituent is by you take a hydrogen off and you add a new carbon-carbon bond onto that chain. That substituent is hanging off the main chain but is covalently bound to it. Okay, so in the case of this, our longest chain is on the bottom here, is these 8 carbons here, right here. And because we have something other than hydrogen on that parent chain, that other than hydrogen thing is our substituent. And in this case, it's a methyl group. Okay, so what we'll be able to do is we'll be able to name the substituent based on the number of carbons in this chain and have it symbolized with this substituent type. So let's continue and look at these rules one by one. Okay, so once we have substituents, we actually have to name them by taking the number of carbons we have, which is the meth, eth, prop, bute, etc. And then we add the YL group to the end. So it's an alkyl group. It's a substituent, so we have YL added to it. The common ones are the methyl group, which is a single carbon, the ethyl group, which is 2 carbons, and there are no constitutional isomers available to it. And now once we get to 3 carbons, we have 2 possible constitutional isomers. We have the straight chain, which we call propyl group, but then we have the branched chain. So this would be a methyl group on an ethyl group, or 3 carbons total, and we call that the isopropyl group, because it's an isomer of the propyl group. So it's the isopropyl group. Okay, once we get to butyl, we now have actual 4 possible isomers. We have butyl, or N-butyl, because it's the straight chain by itself. If we have it in the iso configuration like isopropyl, we can call that isobutyl. Notice this iso group has a CH2 hooked onto it to make it the isobutyl group, okay? So it's a methyl group, and then a 2-carbon chain right here. That's the isobutyl, okay? Now, the next one is if we move this methyl group over from the end to the carbon that's attaching to our parent, we now call that the sec-butyl, and it's short for secondary, meaning this carbon here is the one bonding to the system. And if we were to take this methyl group and move it over one group so that we have 3 things hooked to it, we get what we call the tert-butyl group, or tertiary butyl. That means this carbon has 3 other carbons bonded to it in its group. This carbon has 2 other bonded to its group, it's sec, and this has only 1 other carbon bonded to it, iso. So isobutyl, parent hooked to 1 carbon. Sec-butyl, the parent is hooked to a carbon that's hooked to 2 other carbons. And tert-butyl, the parent's hooked to the carbon with 3 other carbons. Okay, so these are things you'll actually have to memorize because they will be used extensively, and it doesn't fall into any other method. Okay, so let's start with the 7 rules of nomenclature we're going to start with. The first thing is you name the longest unbranched chain you can find and put the ANE at the end, okay? So if you have no branches, you just count the number of carbons, and if it's 10 carbons, it's deca for having 10, and ane, decane, okay? So now, if we have a branch, even 1 branch or many branches, we now have to find the longest carbon chain, okay? If we find the longest carbon chain, then we'll know that we can add that substituent to it. So for example, in this case here, we have our longest carbon chain is going to be 3 carbons, and then we have 1 substituent on it. So we name it for the 3 carbons, which is prop. So we have prop plus ane, so propane is our parent chain, and we have a single carbon attached to it, which is our methyl group, okay? Now, we have to start numbering things, okay? If we have 1 substituent, we want to have that number be the lowest possible. Now, if we were to number this one, we could number it from starting from this side with the 1, 2, 3, or we can number it from this side, 1, 2, 3, and it would give us the same number. That methyl group is on the 2 carbon, no matter which side you name it on. However, if it is unsymmetrical, we can actually have 2 different ones, and we always want to have the substituent on the lowest number. Okay, 1 substituent, the lowest number possible. So in the case of this, we have 1, 2, 3, 4, 5 carbons in our main chain. So that gives us the pent. And then we have ane for being an alkane. So it's pentane. So that's our parent chain is the pentane. And we have 1 substituent on here, and it has 1 carbon. So that's methyl. Meth for 1 and ol for being a substituent. And now we have to figure out which way to number it such that it's on the lowest number carbon. So if we number from this side, we'll end up with 2 is where our methyl substituent. If we numbered from this side, we'd end up with that methyl group on 4, okay? 4 is bigger than 1, bigger than 2, therefore, we have to name it, this is the correct name, is the 2-methylpentane, not 4-methylpentane, because we do not use this 4 because it is not the lowest number for the substituent. Okay, so those are the first 4 rules of nomenclature, okay? Alkane is unbranched, just the number of carbons plus ane. If it has a branch, you get the longest carbon chain, and that becomes your parent, which is the number of carbons in that longest chain with ane. Then if you have substituents, you need to put the substituents what they are by the number of carbons they have and have it be on the lowest number possible. Okay, so rule number 5. If you have 2 or more identical substituents, you still have to choose your parent chain and number them by the lowest number possible, okay? So we're still following those rules, but now, because they're the same, you can add a prefix that denotes how many of those substituents you have, okay? So if you have 3 methyl groups, you can say tri-methyl. If you have 2 methyl groups, you can say dimethyl. If you have 4 ethyl groups, you can say tetraethyl, okay? So you just add that to the number, but you still have to number each of them. So in the case of this compound here, we have 1, 2, 3, 4, 5, 6 carbons in our primary chain, which gives us the name hexane. Hexane, right here. And now we have to number, if we numbered from this side, we'd have 1, 2, 3, 4, 5. And so we'd have a 3 and a 5. If we numbered the other way, we'd end up with, let me change colors here to make it easier. Let me change it to red. So if we named it the other way, it would be 1, 2, 3, 4, 5, 6 right here. So our substituents would be on the 2 and the 4, okay? So since 2 and 4 are lower than 3 and 5, the correct name would be 2, 4 right here. We have 2 methyl groups, so we have methyl as our substituent, and we have 2 of them, so it's di, and then we have our parent as the hexane. So the correct name for this is 2,4-dimethyl hexane. Okay. Again, we can't use the 3,5 because those are higher numbers than the 2,4. Therefore, to have us an unambiguous, exact constitutional isomer, we have to name it the same way we do every single time. Okay, so that's rule 5. So let's add another rule. What if the 2 substituents you have on your parent are not the same? Okay, when we have 2 substituents that are not the same, we put the substituents in alphabetical order, not including di, tri, tetra, using the actual group it is, and then you number from the lowest amount possible. Okay. So in this case here, we have 1, 2, 3, 4, 5, 6, 7 carbons here. So that's going to give us our parent as heptane, right here. And we have a methyl substituent and an ethyl substituent, okay? Since ethyl comes before methyl in the alphabet, we label it ethyl methyl heptane. Okay, so now we need to figure out the lowest number, okay? The number from the end of the chain that gets the lowest, that gives the substituent encountered first, the lower number. So because we are 1, 2, 3, 1, 2, 3, we now, one of these is going to be 3 and one of these is going to be 5. Since we have this comes alphabetically first, we want to have that number have the 3 position first and the other one is 5. Okay, so if they would be the identical numbers just swapped, you always put the lowest number with the alphabetically first order. So instead of having the 3-methyl, 5-ethyl, we're actually going to put it in alphabetical order, 3-ethyl, 5-methyl alphabetical order, parent chain at the end. Okay, so that's rule number 6. Okay, but it can get even more complicated than that. Okay, so when we have multiples of the same, right there, we do not include the di, tri, tetra in the alphabetization, okay? Now, that doesn't work for iso or tert because that's actually part of the name. So iso and tert and sec are included in the name, but not multiples, not di, tri, tetra, okay? So that's a subtle difference there. We need to pay attention to that. Okay, so when we're naming this compound here, we have 1, 2, 3, 4, 5, 6 so we have a hexane as our parent right here. We have 1, 2 methyls and an ethyl. Okay, so we're thinking, oh, dimethyl, dimethyl, because we have 2 methyl groups. Okay, but di doesn't count for alphabetization, which means our ethyl group comes before methyl. So our first group has to be ethyl, okay? So, and then our 2 methyl groups are on the same thing, so we need to start figuring out where those numbers are. Okay, So now we know our rules give us ethyl first, and then dimethyl second, because the methyl, and then we have our parent as hexane. Now let's apply our numbering rules. We want to have the first substituent on the lowest number. So if we're looking from this end of the chain, this would have it 1, 2, 3 is the first substituent numbering from that side, but we have 1, 2 if we number from that side. That means that that is our first substituent in the long chain, so that's the way we number the system, okay? So notice in the previous example, it looked like the number and the alphabetization work together. In this one, it doesn't. So they are different rules and applied at different times, okay? So we have the alphabetization rule, except for the prefix. So that gives us the ethyl and the methyl right here. Now we have the numbering rule because this is the first substituent on the chain. So that gives us, each of these methyl groups is on that 2 carbon. So we have 2, 2 dash dimethyl hexane, okay? But because the ethyl comes first, we have it also on this 4 carbon. So it's 4 ethyl dash 2, 2 dash dimethyl hexane, okay? So that's the 7th rule of nomenclature, okay? So we're going to add to these 7 rules as we add functional groups, as we have double bonds, as we add other things. But these first 7 rules have to be followed, and they have to be followed in order every single time. So get used to these 7 rules in this order. Okay, now that we have different numbers of carbons bonded to our chain, if we only have a straight chain, we only have 2 kinds of carbons. If we have these multiple branches, we could have different types of carbons, okay? And we define those by how many other carbons are bonded to that carbon, okay? So for example, right here at the end, we have a CH3. So we have a carbon bonded to 3 hydrogens, but it's also bonded to 1 carbon, okay? So that means that that one is a primary carbon because that carbon's only bonded to 1 other carbon. If the carbon is bonded to 2 other carbons, that makes it a secondary, okay? And that's what this little thing right here means, secondary right here. If the carbon is bonded to 3 other carbons, and a hydrogen, or something else, it's a tertiary, and if it's bonded to only other carbons, then it's a quaternary. So in this case here, we have carbon, 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 making this the quaternary carbon. Here we have it a carbon, let me change colors real quick. We have it bonded to this carbon and this carbon, which makes it a secondary. It's bonded to 2 other carbons. And notice it has 2 hydrogens on it. If I change colors one more time, this one's bonded to 1, 2, 3 carbons, which makes it a tertiary carbon. And this one right here is at the end. It is a primary carbon, but we also have this primary carbon, this primary carbon, this primary carbon, and this primary carbon. So we have a total of 5 primary carbons on this compound. Okay, so let's actually look at this name too. Okay, we have pentane, which means our longest chain is 5. So we have 1, 2, 3, 4. Actually, let me do it in black here. We have 1 carbon, 2 carbons, 3 carbons, 4 carbons, and 5 carbons in our chain. We only have methyl groups here. And we can number it from this side or this side to get to the lowest number, because this would be on a 2 and this would be on a 2 as well. However, we have 2 substituents here. And so we want to put the 2's on this side, so it gives us the lowest total number. If we numbered it from this side, it'd be 2, 4, 4. If we number it from this side, it'd be 2, 2, 4. We have 3 methyl groups, so we have tri-methyl 2, 2, 2, 2, 4 dash trimethyl pentane. Okay. So we're going to try a lot of other things like this in our homework so that we can understand how to use all 7 rules and get to the same compound name each and every time. Okay. So to move on, once you move from the straight chain hydrocarbon, which has the general form number of carbons plus 2n plus 2 for a straight chain carbon. If we take off 2 of those hydrogens and turn it into a ring, we end up with a different general formula. We lose 2 hydrogens when we make the ring, but it's still a fully saturated hydrocarbon. And so the general formula is the number of carbons times 2 times that number of hydrogens, okay? The most common of these are 5-membered and 6-membered rings, okay? But it doesn't mean it's only forms those. We can form anything from 3 members up to hundreds of members if needed, okay? So when we talk about these things, we talk about that if it was open, it'd be an alkane. And so we put the number of carbons that are associated with the open ring. But if it forms a ring, we have to name it cyclo. Okay, so name each substituent on the ring after that. If there's only one substituent, you don't have to give it a number because it's on, you assume the substituent is now on your number 1 carbon. If there's 2 substituents, you have to go in the lowest number alphabetically. If 3 or more, again, you get the lowest number of sets. And of course, list them alphabetically. So let's look at a couple compounds and use those new rules to give us what we have. Okay, so let's see. This is going to be giving us a ring, and there's 5 carbons in that ring. So that means our parent is pentane, but it's in a ring, so we call it cyclopentane, okay? It has 1 substituent. So that means it must be on the 1 carbon of there, so we don't need to include it. Now, this substituent isn't just a methyl group or an ethyl group, it's an isopropyl group. So that means that, number 1, we'd use it alphabetically with the I. So it's isopropyl cyclopentane, okay? So let's look at the next one here. So we have a ring here. We have the ring, and there's 6 carbons in it. So that gives us the name cyclohexane. Okay, so when we have the ring and it's the biggest number of carbons, we have to name it for that. And so we have cyclohexane. And now we have 2 choices here. We have 1 group here and 1 group here. This group is the methyl group. So that's an M. This group over here is the butyl group, but it's tert butyl. Notice that this is separated by a dash. So because it's separated by a dash, it counts as a di or a tri or a tetra. So we do not use that in the naming structure. So the B comes before M. And so since we have it 1, 2, 3, 4, we name the lowest alphabetically with the number 1. We name the next one with the remaining one, which is the number 4. So we have 1 tert butyl dash 4 dash methyl dash cyclohexane. Okay, let's use that alphabetization rule again with this disubstituted cyclohexane. Again, we have a cyclohexane here, and we have 2 groups. We have, this is a isobutyl group. Notice that it's all one word, isobutyl, there's no dash. If there's no dash, it's all part of the word. And so we have I comes before M, and we have, since the I, we'll give it, that is the number 1 designation. The next one is on the number 2 carbon, and we have 6 members in a ring, so it's cyclohexane. So it gives our name as 1 isobutyl, 2 methyl cyclohexane. Okay, I said we can have these rings in any sizes from 3 up. And so let's do this last one right here. Our ring here is cyclopropane. Okay, we have 3 carbons, so that's propane, but it's a cyclopropane, so it's cyclopropane. Okay, we have 2 substituents on it, and they're both on the same carbon, so great, we get to name them both number 1 right here. And we have an ethyl group and a methyl group. E comes before M alphabetically, so it's going to be 1 ethyl, 1 methyl cyclopropane. Okay, so we have those 7 rules of nomenclature for naming hydrocarbons, and then we add that new rule with the cyclos where we have the ring structures in them. So that gets us to the end of Chapter 3, Section 2.